And I really want to appreciate IEOM for this opportunity to present my paper, and with regards the authors of this particular paper. And so uh, my topic here to present is locating a cement distribution facility using the center of gravity. Um, it's a case study model anyways. So looking at the background of this particular paper, you see that solving a supply chain network design problem for a cement manufacturing and distribution company in Sierra Leone using the center of gravity model is um, critical in light of the underlying issues of weighted demand for cement products. So this is because according to the study in Sierra Leone here, only wholesalers are recorded for customers to access product, and they are relatively not close enough to cover or basically to customers. So there are no sufficient warehousing facilities in the country, in major cities, to hold a larger amount of cement products so that consumers' demands can be significantly met. So in this case, most customers who went to wholesalers to get products found that the product was not available, which caused congestions and overcrowding at the wholesalers' location. So this is basically to reduce the time it takes for vehicles to transport goods to different parts of the country, the distance the road freight must travel from one location to the other to transport goods, and the resources required to meet customer demands. So this is basically the background of this particular research. So from the research paper, I took just few previous researches from the paper just for the sake of the presentation. And so looking at this first research from Berman 2006, it says the goal of location problem is to identify location of new facilities to capture as much of the available demand as possible. An important feature of our model is that it assumes that each customer will tend to patronize the most convenient, meaning like the open facility, right? And so taking LIO 2008, it says clustering-based location allocation method. So the capacitated facility location problem, which is the CFLP, provides an approximately optimal solution. It determines the location and coverage of a set of facilities to serve the demands of a large number of locations. This allocation is constrained by facility capacities. And so take into account Plastria 2001, it says a location model is said to be about competitive facility when it explicitly incorporates the fact that other facilities are already or will be present in the market. So the apparent simplicity of this particular statement hides several implicit and explicit notions which have to be made more precise before a clear and well-defined model arises. So what is the goal of this particular research? Now we have two particular main goal of this research. Yeah, we say the main goal of this research is to locate a cement distribution center, which is the DCs, for facility at strategic locations to serve major cities in all four regions of Sierra Leone in order to increase customers' weighted demands. Because Sierra Leone, we have four regions, which are the north, the south, the east, and the west. So this research is trying to see how best we can have facilities, just to respond to the customers' weighted demand. So the other goal here is for giving customer demand and a list of potential distribution centers. The main concern is to find distribution centers and assign customers to them in such a way that total distribution cost and delivery time are minimized. And so looking here at the research methods which are employed in this particular study, I took into consideration the data collection. Here we say the data collection techniques use the primary data and secondary data approaches, which are empirical data, and from this review of other researches on similar studies. You know, this is the global pandemic, and so it is quite well difficult for you um, to meet people one-on-one, face-to-face, and then try to gather data. But we use that kind of secondary data from other writers, what they've done before. So this is just the population and the region, of course, the longitude and latitude of major cities in Sierra Leone. Yeah, I took into consideration 9 major cities in Sierra Leone. We have the first one, which is Freetown. Freetown is the capital city of Sierra Leone. And of course, we have Bo as well is the capital city of Sierra Leone, but it's the second capital city because it is the second largest city. We have Kenema, which is at the eastern parts of Sierra Leone. We have Kono and Kailan. They are all at the eastern part of Sierra Leone. Of course, we have Makeni, where of course I am staying currently. And then we have Lonsai, we have Potloko and Kabbalah. So these are basically the major cities in Sierra Leone, which the research is basically taking into consideration. Yeah, so now under the same research methods, we have the data processing. Of course, in trying to analyze this particular weighted demand of cement factory or cement distribution centers, we try to explore the Excel solver. Well, Excel solver, it's an add-in or program used for body analysis. Yeah, it finds an optimal or either to maximize or minimize value for a formula in one cell called the objective cell. So solver works with a group of cells called decision variables on simply variable cells. Yeah, so this is the solver parameter, which is being shown here as to how the particular data was analyzed to have the result. And so here we say under the results and analysis discussion, we say the study conducted for 9 cities in 4 regions, of course, which I've shown earlier. And so this one shows basically the distances from one location to the other, from one city to the other. But putting all that together, it gives a total of a total distance of 324 miles, of course, which is equivalent to 521.316 kilometers. So the quantitative technique used is to determine the optimal location of a facility based upon minimizing the transportation cost between the production center and the distribution center. So here is the distance, because using the Excel solver, it's arrange the distance from one city to the other, you know, with regards to all the 9 cities which are from the 4 main regions. So from Freetown to Freetown, we know the distance is 0 because it's the origin point. So from Freetown to Bo here, you see the distance 108, 145 respectively. So this is the distance from Freetown to the other locations and from Bo to other locations. So it's a row against the column. You see the distance respectively. So this is the total whole distance, which is 324. Yeah. And so moving on to the result analysis stage, again, we see now having employed the Excel solver, we find out that the yellow shaded cells, yeah, these yellow shaded cells show the warehouse established in each city. So the data before the Excel solver analyzed shows that a total number of 10 warehouses or distribution centers to be served by all the 9 cities. So which is basically huge, and it's really exorbitant because we know the underlying problem is we don't have distribution centers, or that we only have a production center in Freetown, which is the capital city, and considering the distances to be covered by all of the other cities in the 4 main regions. So here we see Freetown is serving the population with 1 warehouse, Bo warehouse as well is to serve center is to serve the population of 2 cities, and Makeni distribution center is to serve the population of 4 cities. So the number of warehouses determined to serve all 9 cities is 4. But we look at it that this is really huge, but we want to minimize the total distance to cover, because this aspect is for us to minimize the distance and then save cost in order for the customer's demand to be met in a timely manner. So the Excel solver helps us with this particular distances. So we know from Freetown to Freetown, we have just one warehouse. And so this warehouse will serve Freetown itself. So another warehouse will be in Bo, which will serve. This is also against Ro and the Colon. Bo warehouse as well will serve Bo and Kenima, and of course Kailaung, because the distance approximately they are really relatively closer together. So basically one warehouse will serve like 2 or 3 cities. Yeah. And so looking at Kenima, there is no warehouse here in at Kenima to serve all the cities, but Kenima falls under Bo, which is to be served. Here is Kenima, and here is Kailaung. So Kenima from this point has no warehouse, but Kenima will access the facility from Bo, which is the closest point. And so considering Kono as well, Kono is on the east part of the country. So Kono is to be served, of course, Kono itself, and then of course Makeni. So this particular point, you see that Makeni is to be either served or served Kono, and then Makeni itself and Losa, because these are close points. So you have a total, of course, looking at Makeni as well is to serve Kabbalah, because the distance are very much closer together. So it minimizes the
Daniel,
distance.
I'm sorry, could you please make it faster?
Yes. So it minimizes the distance. And coming to the Excel server, because we want to know how many warehouses we are to construct or we are to institute. So we have Freetown, which will hold just one warehouse to serve both local, and Bo we have it to serve Bo itself, of course. So the total number of warehouses which the Excel server has organized for us is 3 instead of 4, and then or 10 to serve the 9 major cities. So we have there a reduced distance, yeah, upon the number of warehouses and the distance clustering which the Excel server has conducted. So we know that we have 292 miles, which is relatively the distance is much more reduced as to the initial old distance. So upon this, we have our conclusion. Now, Freetown, which is the capital of Sierra Leone, used to serve all other cities in the various regions population with one warehouse, a reduced total distance of 292 miles, which is equivalent to 469.828 kilometers, and a total number of 3 warehouses, distribution centers to be established in the country to serve the population of 9 major cities will enable the company to overcome the delay of product delivery to these customers at the various points. So this is the end of my presentation. I want to thank you for your audience.
Okay, thank you, Mr. Daniel. Okay, please, audience, ladies and gentlemen, give your questions or comments to these interesting questions about supply chain network by using center of gravity method in Sierra Leone. Please, audience, do you have any questions? Or maybe sharing your similar research in this topic? Not yet? Okay, Mr. Daniel, I noticed in your paper, it's also written with Mr. Wahyudi Sutopo and Mr. Hisam, right? Okay, so but you use your Sierra Leone as the case of study. I believe this your country, Sierra Leone.
Yes.
Am I correct? Yeah.
Yes.
Okay, then. Yeah, because of the online method of learning. Yeah, I know that. Okay. My question for you is how if we implement those methods in Indonesia? Can we use similar method, exactly similar method, or do we have to make a anything that we have to rearrange, so we can implement in Indonesia?
Well, taking into consideration the demography of Sierra Leone and Indonesia, you find out that Indonesia is much more bigger, it's much more larger than Sierra Leone. Sierra Leone is apparently like 6.1 million people as a population. So our regions, yes, are not that big as compared to Indonesia. I've not been there, but I've not been there before, but from other studies, other researches online, you'll find out that Indonesia is a very big city. And of course, the research could be an improved one as to this one, because I limited my research as to the demography of my country, because here we don't have trains, trains like moving from one point to the other as like train, but here we have other vehicles, to convey goods from one place to the other, because I know Indonesia is a very big city, it's a very big country, so moving from one place to the other, I know you have trains, I know Indonesia has ships to convey goods, but here we only have ships coming in from other countries. But this research could as well be used in Indonesia to, but it could be in a more improved manner, taking into consideration all of the transportation system in Indonesia. Yeah, so basically, this study could be used in Indonesia with an improved method. Basically, that's why.
Okay. Thank you for your opinion. This was very interesting study. Thank you, Mr. Daniel. Let's give a virtual applause to Mr. Daniel.
Thank you.
Thank you. Congratulations on your study in Universitas 11 Maret. Yeah, we are continuing to another speaker.